When doing integration by parts, this is a technique that we need to use whenever we're trying to undo the product rule. Just like use substitution, reverse the chain rule, integration by parts will reverse the product rule. Now, notice in example 1, they've given us the description of the derivative of u and v, and they've separated it so that we have u prime times v plus u times v prime. Now what we're going to do with this is integrate both sides. So in other words, I'm going to have the integral of d dx of uv dx is going to be equal to, and then we're going to integrate all of this other side. Now do keep in mind to rewrite this, we have v and then u prime, that's the same thing as writing du dx, and then we are again integrating with respect to x, so we're going to put our dx just like we did over here, plus, and then again over here we're going to have our u, and then v is the same thing as dv dt, or I'm sorry, not t, dx, and then again times the dx because we are integrating. Now if I integrate this derivative, I'm just going to be left with uv because again integrating is that antiderivative, so it's going to undo that. And so that's going to be equal to, and then over here I'm going to cancel those, so I have the integral of v du, and then plus, and then I have the integral of u dv. And so finally we develop our formula. We're going to subtract this first integral over. So uv minus the integral of v du, that's going to be equal to u dv. And that is going to be our integration by parts. Now you certainly do not have to memorize how we get this formula. However, you do need to know the formula itself. And a lot of times you will hear the integration by parts. We're going to call uv, that's going to be sunshine, minus, and we call this other part voodoo. So either memorize it that way or just all the different parts. That's going to be your integration by parts. So looking at this, and they give you some steps to help you try to pick what you need to let each part be. And so there's a couple of ways you can go through and read. One of the better things they tell you in the first two examples is that dv, you need to let that dv portion be a complicated part that can be easily integrated. And then u is going to be a part whose derivative is simpler than the function that you're starting with or that you're given. This goes through a good process. And then like it says in part 4, you only have two choices. So if one doesn't work, try another. So let's go through this classic integral of x times e to the x. And choosing things that are a little bit easier, notice that I would choose here x in place of u. And then the derivative of u is going to be just 1 dx or dx. Now this one you're working down, but over here you're really going to work upward. So if I let that u part be x, then I'm going to swap over and let the other part, which is going to be this e to the x dx, that's going to be our dv. And now we need to integrate. We're moving up this chain, and if I integrate e to the x dx, I get e to the x. So it looks like this might work out. Now our formula, going through the steps for that, we're going to have uv minus the integral of v du. That's your sunshine minus your voodoo. So for the first part, you're going to multiply these two together, u times v. So your direction, multiply those two. So I'm going to have x times e to the x minus the integral. of v, so we're at v, which is e to the x, and then times du, which here we're going to get dx. And notice this is now something that's a little bit easier to integrate. And so we're going to continue on integrating. So we have x times e to the x minus, and if I integrate here e to the x dx, I get e to the x. And then we also have plus c because we don't have our endpoints. So here's going to be our entire answer. All right, moving on to our next example. Again, another good example here of how to pick apart all of this. And this is a classic problem. You could actually see the same problem on the AP exam. So your first part here is kind of tricky because a lot of people want to separate natural log and x. You can't. This is all one term. So you're just going to pick. It's like, okay, I'm going to try natural log to be u. When I do the derivative of u, I'm going to have 1 over x dx. And if all of that is natural log of x, then dv, it seems tricky, but you're going to make that dx. And if I integrate dx, then I'm just going to get x. And the reason why is if I integrate just a dx, remember there's really a 1 there. And so what did I take the derivative of to get 1? I took the derivative of x. So that's where that's coming from. Now let's go set up and see if we've chosen the appropriate values. So again, my formula is uv minus the integral of v du. So u times v, so again I'm going to multiply across here, so I have x times natural log of absolute value of x. And then we're going to have minus the integral of v du. And du is equal to 1 over x dx. And so notice that we'll simplify down to be something a little bit easier to integrate. Notice these x, 1 over x, and x will cancel. So I have x times natural log of the absolute value of x minus the integral of dx. And again, if I integrate just dx, that's really 1 dx, so I'm going to get x, and then I have plus c. All right, for our next example, it's more of the same. And again, we can mix up what we choose. However, I would always try to let u be equal to this easier term to deal with. So I'm going to let u be x. And if I do the derivative of x, of course, I get 1 dx. So then that would mean that I have over here e to the negative x dx. And that's going to be for my dv. Now I need to integrate this, and do remember we can come over here to the side and look at integrating e to the negative x dx. And I think we have done a u substitution with this, and so this does come up, and so we see that du is going to be a negative dx. So notice that we need to divide by that negative 1 to solve for dx. And so we can go ahead and put in that we have our negative there. And if we integrate e to the u, we get e to the u. So I'm going to have a negative here, and then e to the negative x. Okay, now we're ready to go over here and do our integration by parts. So we are going to have, so uv, the panel, right? So uv, so that's x times negative e to the negative x minus the integral of v du. So v is negative e to the negative x, and then dx. So before I integrate this second part, I would go ahead and take this negative, and let's move it on the outside. So, and then I would move that negative there. So we have negative x e to the negative x plus the integral of e to the negative x dx. And we already know what the integral of e to the negative x dx is. So we can go ahead and bring all of this down. We have negative x, e to the negative x, and we're going to end up with minus e to the negative x again. And that's going to be now a little bit different. We're not doing plus c because we have our integration, limits of integration. So we're going to go from 0 to 4. All right, so substituting in our endpoints, we're going to have the top. So we have negative 4 over e to the 4th minus 1 over e to the 4th. So there's our first parentheses minus, and we're going to plug in 0 for the next one. So we're going to have 0 minus 1 over e to the 0 power. So this other part we can combine because it does have a common denominator. So that's going to be negative 5 e to the 4th, 5 over e to the 4th. And then over here minus 1. And that should be our final answer. Or I'm sorry, not minus 1. There's minus 1 on the inside and then the negative, so positive 1. All right, so let's try our next example. Again, we have to pick what we're going to be choosing for our u and then our dv. And this time, if we pick x cubed, and y'all don't write this, it's not going to work. But if we continue that same process, then we have a 3x squared here. And then dv is going to be natural log of x. But we saw earlier, integrating the natural log of x is not an easy task. That was all the way back up in one of our, I think, example number 2. So that means we're going to have to swap what we've been doing. So we're going to change that. This time we're going to let ln be u, natural log of x. The derivative of natural log of x is 1 over x dx. And then over on the other side, we're going to let x cubed be dv. And if I integrate that, then I'm going to go back up, and that's going to end up giving us 1/4 x to the 4th. So let's see if that's going to work. So we have u times v. So I have 1/4 x to the 4th natural log of x, so uv, minus the integral of v, 1/4 x to the 4th, times du. du is 1 over x dx. Now let's simplify over on this other side our radical. So I have 1/4 x to the 4th natural log x minus, now this 1 over x will cancel, and so that's going to give me x cubed. And I have a 1/4 there, and I'm going to move that outside because it's just a constant. So I'm integrating x cubed dx. Okay, now that we have that part, let's go ahead and integrate. So we're going to have 1/4 x to the 4th natural log x minus 1/4. And if we integrate x to the 3rd, notice that we do get our 1/4 x to the 4th back. And now we're going to be integrating all of this from 1 to e. So every bit of this is going to be evaluated from 1 to e. And so here, as we're plugging in our value of e, that's going to be 1/4 e to the 4th natural log of e minus 1/16 e to the 4th. So there's our top endpoint. And then minus, and let's do our bottom endpoint, which is 1. So we're going to have 1/4 times 1 times the natural log of 1 minus 1/16 times 1 to the 4th. So here we have 1/4 e, natural log of e. That's going to be 1. So really we have e to the 4th over 4 minus e to the 4th over 16. And then from our other endpoint, natural log of 1, that's going to be 0. So that entire part is wiped out. And then I have minus, and we have a negative here, so that's going to be positive 1/16. And it's okay, you can leave your answer like that. Now, if you really need to make sure you get a common denominator here, do keep in mind these two. You can get a denominator, and that's going to be the only thing you would possibly see put together. Your denominator would be 16, and of course to get something over 4, that's going to be, if we multiply through here, 1/4. Right, so 1/4 there. So we're going to have 4e to the 4th minus e to the 4th. And if you go ahead and simplify that, that's going to give you 3e to the 4th over 16 plus 1 over 16, or minus 1 over 16. All right, so there's going to be your final answer. Okay, so for our next part, we are going to have to rewrite this. So I would first get an idea, arctan, that's going to be the same thing as integrating inverse tangent. Those are the same, inverse tan dx. And so with this one, it's kind of strange what we're going to do, but we're going to let u be inverse tangent of x. And when I do that derivative, I'm going to have 1 over 1 plus x squared. And then our dv would then have to be dx. And if I integrate that, I'm going to get x. So now we're ready to go through our integration process. So we're going to have u times v, so that's x inverse tangent of x minus the integral of v, which is x, times 1 over 1 plus x squared dx. All right, so now we've got something a little bit more familiar with doing our integration. And this part here, this should be a natural log for us. So we're going to have x inverse tangent x minus, notice that if we did the derivative of the bottom, we would get 2x, but I only have an x in the numerator, so that means I need to balance this with 1/2. So the derivative of the bottom is the top, so that's going to be natural log. And then absolute value of 1 plus x squared, just kind of redundant because that's going to stay positive anyway, and then plus c. All right, so moving over to this other problem, I'm going to address this one in class. This one is kind of weird. So for the moment, we're going to omit this one because it's a little more than what the AP exam requires. However, we can discuss it in class. All right, for the last example I want us to look at, for this one, this is going to be a repeated integration by parts, and we're going to see what that is going to imply. So again, we need to pick something that we can take the derivative of pretty easily, and then something we can integrate. And so it looks like we would let our u be x squared. And so du is going to be 2x dx. And then that would leave us for dv to be cosine x. And if I integrate cosine, I'm going to get sine x. So let's see what we have here. We have uv, so x squared sine x, uv, minus the integral of v, and then du, which is going to give us 2x dx. So notice that this first part works out great and wonderful. However, this portion right here, because of that x, that's going to cause us to have to do integration by parts yet again. So they've provided for us a second place over here. So to do that second integration by parts, then I'm going to have to let u, the second u part here, that's going to be 2x. Well, the penal right. So du is going to be just 2 dx. And so that's a good indicator there that we're probably done with this repeating. And then dv, we're going to let that be sine x. And if we integrate sine x, we have negative cosine x. All right, so now we're ready to sub all of that second portion back in. So I'm going to go ahead and I have this minus here, and then I'm going to bracket because our signs could get messed up. We have to be careful. So we have UV, so we're going to have here when I multiply those two together, I'm going to have negative 2x cosine x. So there's UV minus the integral of v, so negative cosine x du, which is going to be times 2 dx. And we can deal with that too. That's going to be a little bit easier. So this problem is ginormous. So let's go ahead and bring down all of our parts. We have x squared sine x from the very beginning. I'm going to distribute that negative, so that's going to be positive 2x cosine x. Now notice I will distribute the negative here. That's going to make it a positive. However, we have a negative 2 right here that we can pull back out, so that's going to make us a negative 2 times the integral of cosine x dx. So we have x squared sine x plus 2x cosine x minus 2 times, and if we integrate sine x or cosine x, we get sine x, and then of course plus c.